This page shows the analog input connections to the Carel PC05 controller. Analog inputs are used for sensors that measure continuous variables such as temperature, pressure, or flow, converting physical quantities into electrical signals the controller can interpret. At the top left, you'll see terminals labeled J2.U1 to J2.GND, which correspond to the first group of analog inputs. SIW, water inlet probe. This is a 10 kilo ohm NTC thermistor used to measure the temperature of the chilled or hot water entering the heat pump. DU, water outlet probe, 10 kilo ohm rated thermistor, measuring the water leaving the heat exchanger. SAE, ambient air sensor. This probe monitors the outdoor ambient air temperature, providing input for defrost logic and ambient compensation. At J3 connector block, liquid probe, SL1, 10 kilo NTC thermistor, used to monitor refrigerant liquid line temperature at circuit 1. High pressure transducer, tap 144 through 20 mm pressure sensor monitoring high pressure side reading of the refrigerant circuit. At J3 connector block, liquid probe, SL1, 10 kilo ohm NTC thermistor, used to monitor refrigerant liquid line temperature at circuit 1. High pressure transducer, TIP1, 4 tiles 20 mA pressure sensor monitoring high pressure side reading of the refrigerant circuit. Analog inputs connected through J6 and J20 terminal blocks are low pressure transducer, TBP1, measures suction pressure in the refrigerant circuit, second liquid probe for circuit 2, SL2, to measure liquid line temp, second high pressure transducer, 420 mA transducer, measure high pressure side pressure at circuit 2. Second low pressure transducer, TBP2, measures suction pressure in circuit 2. Differential water pressure transducer, measures pressure difference across the evaporator, confirming water flow through the heat exchanger. This page illustrates the wiring of the electronic expansion valve module, specifically the Emerson EXD-TEVI controller, labeled EXD1. The EXD-TEVI module precisely modulates refrigerant flow through the expansion valve, EEV, to maintain proper superheat and efficient system operation. At the top left, terminals GND 31.8, TX1 31.8, and RX1 31.8 represent the RS485 communication lines that link the EXD controller to the main PC05 controller. Expansion valve controller connected to the expansion valve through the wiring terminals XCN 10.1.1 to XCN 10.1.5 and powered through 24 VDC at terminal 11 and 12. Suction temperature probe, circuit 1 ST1, secondary suction temperature probe, STE1, pressure transducer TP1, to measure suction pressure at the compressor inlet. We have similar wiring for expansion valve 2 for circuit 2 as well. In conclusion, understanding an air-to-water heat pump wiring diagram is about more than following lines and symbols. It's about seeing how electrical logic drives the entire refrigeration and hydronic process. We began by tracing the main power distribution, from the incoming three-phase supply to the fuses, circuit breakers, contactors, and overloads that protect and control each major component, compressors, pumps, and fans. Next, we explored the low-voltage control circuit, where relays, sensors, and safety devices communicate with the central controller. In this case, the Carel PC05+. Each relay or contactor represents a specific operation stage, whether it's starting a compressor, energizing a solenoid valve, or switching a heater. Don't forget to subscribe to get notification for next video on wiring diagram reading series.